Hello students, this is Miss Littlejohn. I'm going to take you through this carbon and water cycle doodle notes in Cami. So when you open it up in Canvas, it should take you right to Cami, which is a Google extension that you might have to add on if you don't already have it. This little icon up here tells me my extensions, and just let me know if you need help with that. So we have a drawing here, but what we need to do is draw the lines and the labels of the processes, and then we've got some notes related to these terms down here. So over here on the left panel, you've got some drawing tools. You can use this drawing tool, or you can go to shapes and insert a line in order to draw your arrows. I kind of like the drawing tool. You can change the color. I'm going to use green for the first couple of arrows because they are biological processes, and I want to differentiate those from the non-biological processes. So the first one is photosynthesis. You have photosynthesis removing carbon from the atmosphere because the plants are pulling in carbon dioxide. So I'm going to make a label up here called atmospheric CO2. I think I'll color it red and make it a little bit bigger. Then I'm going to go back to my drawing tools, and you can change the weight of your line here. So we've got CO2 going into the trees and other plants. And I'm going to come back and label that as photosynthesis in a bit. And then we have respiration. So you have producers and consumers putting CO2 back into the atmosphere, and that is also a biological process. So I'm going to draw an arrow going this way from the plants and from the horse. I'm going to click on the text tool and type in photosynthesis. I'm going to change the color. Let's make it green. And I don't think that one needs to be quite so big. I tried to find a way to turn the text box, so that it kind of lines up with the direction of my line, but I can't figure out a way to do that. So I think it's not going to let us, but if you guys discover how to do that, let me know. And then these arrows are representing respiration, so let's label that process there. So here we have two biological processes, one of them removing atmospheric CO2 and the other one putting CO2 back into the atmosphere. And then I'm going to change the color because I wanted my non-biological processes to be different. So over here we have industrial emissions at power plants burning fossil fuels and putting CO2 into the atmosphere. We have transportation also burning fossil fuels, putting CO2 into the atmosphere. We have CO2 being absorbed by the oceans. Let's say this is our ocean over here. When things die and decompose, here's some decomposition. Then let's say these producers and consumers die and decompose, that all the nutrients in those living things get recycled, put back into the atmosphere. So that's going to represent our decomposition. If conditions are just right, some of those dead things become fossil fuels, although it takes millions of years and just the right environmental conditions for that to happen. So this black blob over here on the left represents our fossil fuels. So let's go add some labels. So over here we have power plants and factories. I think I'll make my text black there. And then what else do we need to label? We have transportation. Specifically burning the fossil fuels. And I want to point out the word burning or combustion of the fossil fuels. Simply the existence of a fossil fuel isn't contributing to the CO2, it's the burning of it. There's carbon in sedimentary rock, as the name implies. It's sedimentary rock is compacted sediment. It's basically cemented together into rock, and there's living things in there. That's where we find fossils, and that's why there's carbon in there. So if you asked about this, you have to say sedimentary rock, because not all kinds of rock have carbon. It's the sedimentary rock. And a good example of sedimentary rock, let me type this in, is limestone. Let's label our ocean and label our decomposition. Fossil fuels. Whoops. That is coal, oil, natural gas. Takes millions of years. Some people wonder what the problem is with burning the fossil fuels in regard to atmospheric CO2 and climate change. And two things. One, CO2 holds warmth in the atmosphere. It's called a greenhouse effect, which is a good thing up to a point to make the Earth habitable. But if the increase in warmth happens too fast or too much, then that creates problems for living things. And then also that CO2, or that carbon rather, has been stored in the fossil fuels for millions of years. So the CO2, I'm sorry. So the carbon has been sequestered in the fossil fuels, means stored away. Sequestered means stored away for a really long time. And it's been stored there for millions of years. And we are putting it back into the cycle, specifically into the atmosphere, very, very rapidly. And so it's creating a more dramatic change than we would see naturally. All right. What are we missing here? Okay, we need to label waste. We've got our sedimentary rock, ocean, transportation, burning fossil fuels. Also, the power plants and factories are burning fossil fuels. And I think that's it. Now down here, we got to write some stuff about the notes. Photosynthesis. Producers take in carbon dioxide from the atmosphere to create organic compounds such as sugars. You might be asked at some point to name an organic compound in the process. Organic means you've got carbon with the carbon-hydrogen bond specifically. And so oxygen is not an organic compound. Carbon dioxide is not an organic compound. But sugar is an organic compound. It's got that. It's C6H12O6, and it's got the carbon-hydrogen bonds. So it's very helpful to remember the formula for that. CO2 plus water as our reactants, and our products are oxygen and sugars. For cellular respiration, This seems very, very basic, but you'd be surprised how many students every year miss questions about these two things. Producers and consumers digest compounds and release CO2. I'm not going to bother making all my subscripts right, even though it's bugging me a little bit, but you can do your subscripts right there. Deforestation, you guys know that is a cutting down of trees. The problem is that prevents carbon from being sequestered and stored, which means stored in the trees. And then if the trees will decompose, or some of them, or which would take a really long time, but sometimes they're burned and then the carbon's entering the atmosphere right away. So we'll type prevents carbon from being sequestered. So this is a human impact on the carbon cycle. I'm trying to type fast. Okay, burning of fossil fuels. So as I mentioned, the carbon from ancient previously living things is stored in those fossil fuels, and burning the fossil fuels releases that carbon into the atmosphere in the form of carbon dioxide. Stored carbon from ancient living things. Burning fossil fuels. I already mentioned what are fossil fuels. Coal, oil, and natural gas returns carbon to the atmosphere. Ocean acidification. So the ocean is absorbing a lot of CO2, and when the CO2 is absorbed to the ocean, it creates carbonic acid. That's a chemical reaction that happens, and that is, as the name implies, it's acidic, and that can lower the pH of the water. And if it's lowered significantly enough, it can actually dissolve the shells of species that have shells, like corals and mussels. Excess CO2 is absorbed by ocean water and creates carbonic acid. This lowers pH and dissolves the shells of species such as coral and mussels. The largest reservoir of the ocean, I just gave you the largest reservoir is of carbon. The largest reservoir of carbon is sedimentary rock and sediment at the bottom of the ocean. All right, and there's your carbon. The water cycle is going to go even faster. This is the easiest one always. So I'm going to go to my drawing tool, and I like this blue. We've got, you guys usually know this, evaporation, condensation, which forms clouds. I'm not that good at this. Precipitation. Some of that precipitation is going to infiltrate into the ground, seep in, and it's going to recharge aquifers. This is an aquifer down here. Groundwater is underground versus surface water, which would be like this, a lake or a stream. And then some of it is going to move horizontally across the land and go into the ocean or the lakes or whatever, and we call that runoff. Some of it will evaporate from the leaves of plants, and we call that transpiration. So let's label the processes: evaporation, condensation, precipitation, infiltration, runoff, and transpiration, groundwater, which is going to be an aquifer. And I think that's it. Yes. Okay, let's fill in our notes. Evaporation is when water turns from liquid to gas. I know, I have mad typing skills, except when I go fast, I keep making mistakes. Water transpiration is water traveling up through plants and out of the leaves as vapor. I have a joke for you guys. What do you call a deer with no eyes? No eye deer. What do you call a fish with no eyes? Psh. Dad jokes. Water vapor creates clouds in the atmosphere. Precipitation, that's water falling from the atmosphere. It can be snow, sleet, rain. Runoff is the path precipitation takes across the ground to rivers, streams, lakes, ocean. Something we'll talk about later is as the water moves, it's going to pick up pollutants and it'll take it to the lakes and streams. Seepage, water that soaks into the ground. The word you'll see more commonly is infiltration. Groundwater is water stored underground. The upper limit is called the water table. So if the light gray up here in the illustration is the aquifer, the top line is the top of the water. So if you're drilling a well, you want it to get at least to the water table, right? So that you have access to the water. The water table can lower if more water is being removed than is naturally recharged by precipitation. And something that you need to consider is when we are building up our cities and we're putting in impervious materials, meaning water can't soak through, we have driveways and roads and parking lots and building foundations, then we're not going to get the recharge of the groundwater that we did before, and that creates a big problem. So the largest reservoir, I bet you guys can take a guess, is the ocean. And that is it.